smaller than negative 4, I think about on the graph, what are the y values getting closer to? Well, the y values are getting closer and closer to the value positive 2. Likewise, as I come from the right, okay, take numbers a little bit bigger than negative 4. If I think about what's happening to the y values on the graph, again, those are getting closer and closer to 2. So I would say yes, and we can write the limit as x approaches negative 4 of our function. We would say that that equals positive 2. Again, the y values are getting closer and closer to 2. So again, notice the y value at negative 4 is something totally different. But again, it doesn't matter what actually happens at that point. We just think as you get close to negative 4 on the left and on the right, are the y values there getting close to some specific number? Yes, and in this case, that number is 2. Same question, does the limit as x approaches 5 exist for f of x? Well, if I come in from the left, okay, so here the y values are getting closer and closer to some, whatever it is. Let's pretend it's up here at positive 4 just to give it a specific value. So here as we approach from the left, the y values are getting closer and closer to 4. But then when we come from the right, well, if I look at x values a little bit bigger than 5, well, now the y values are getting closer and closer to something different. Let's maybe pretend that that's, I don't know, positive 1. Well, since when you come from the left, the y values on one side get close to 4, and as when you come from the right, the y values get closer and closer to something different, in this case, positive 1. If the limit as you approach from the left and from the right is not the same, we say no, that limit does not exist. And kind of another way I always thought, for a limit to exist, for example, at negative 4, notice if I kind of put my fingers on the graph and bring them in closer and closer and closer to negative 4, they're going to basically touch. Okay, they're going to get closer and closer and closer, and that y value where they would sort of be touching would be the y value of 2, and the limit exists. If I do the same thing at x equals 5, if I put my finger, on the graph and try to, move them close, take x values closer and closer to 5, I think, well, are my fingers going to be touching? Are they getting closer and closer together? No, because one's up here, one's down here. If that happens, we say the limit simply does not exist. Okay, so just one more example here, finding limits graphically. So suppose we've got the function g of x, a piecewise function. It's x squared plus 1 for x less than 0, 2x plus 3 for x values greater than or equal to 0, and we want to know what's the limit of g of x as x approaches negative 2. So I think, again, we're talking about doing this graphically, so let's graph these two functions here. Hopefully, shouldn't be too bad. Hopefully these are functions that you recognize from algebra. Remember, x squared plus 1, x squared is just going to be a parabola. The plus 1 shifts it up 1 unit. But since it's only defined for x values less than 0, well, okay, so normally, again, it would have a y-intercept at positive 1. But since we're only using x coordinates less than 0, we're only going to get the left half of that parabola. Okay. When we go to graph 2x plus 3, well, that's just a line that has a y-intercept of positive 3. Okay, and since it's defined for x greater than or equal to 0, we're going to shade that in. And recall, the slope in this case is just going to be positive 2. So it's just going to go, kind of off and to the right. So again, we're kind of asking ourselves, what is the limit as x approaches negative 2 of g of x, if it even exists? Well, in a sense, okay, so we're sitting over here at negative 2. What's going on with the line is really, in a sense, completely irrelevant for this problem. So kind of a little bit of extraneous information, maybe just to, make sure that you understand that you don't need it. Okay, so again, this is the function x squared plus 1 on the left. If we plug negative 2 in, we would get, well, negative 2 squared plus 1. So this would be the point sitting on our graph. That would be the point negative 2 comma 5. And again, we're asking ourselves, what's the limit as x approaches negative 2? Well, if you take x coordinates a little bit smaller than negative 2, and if you take x coordinates a little bit bigger than negative 2, I kind of put my finger again on the graph like I